This video goes over how to write the equation of a piecewise defined function when you're given the graph of that function. And if you look back in your notes from class, you'll recall that the function looks something like this. You'll remember that there's going to be two parts to our equation, because as we look at our graph, there's two parts to our graph. There's this part right here, and there's this part right here. I'm going to draw in a dotted line at x equals -2, because you'll see that we've got two different rules that our function follows depending on which side of -2 we're on. So we need a rule for when I'm on the right-hand side of -2, and we need a rule for when I'm on the left-hand side of -2. You'll notice I chose to put less than or equal to -2 right here because of the closed circle, and that's important. A closed circle at -2 versus here I had an open circle at -2 right here. So we know that for numbers from -infinity to -2, we're going to follow one rule, and for numbers -2, or rather bigger than -2, we're going to follow another rule. What this comes down to now is simply writing the equation of both of these lines. So I'm going to call this section A and section B, and we want to write the equation of line segment A. By inspection, I see that the slope of this line appears to be 2. We count up 2 and to the right 1, up 2 to the right 1, up 2 to the right 1. The slope is 2, and we know that to write the equation of line we just need a slope and a point. So I'm going to use the point -2, 4, which is this point right here. And write the equation of the line. I'm going to say y minus 4 equals 2 times x plus 2. I'm going to solve for y. Y minus 4 equals 2x plus 4, which means y equals 2x plus 8. So I'm going to take this equation, or this rule, 2x plus 8, and we see that this corresponds to the section of the graph when x is less than or equal to -2. So I'm going to write 2x plus 8 down there. That's the rule that we follow when we're at -2 or below. Now we need to go back and write the rule for segment B. We're going to do the same idea with a point and a slope. We see that the slope, it looks like it's -1/2 if you count. Starting at this point, down 1 to the right 2, down 1 to the right 2, and so forth. But you'll notice what's easier about this one. The point that I'm going to choose to work with is the point 0,6, which happens to be our y-intercept. So we can just say right off the bat our rule is -1/2 x plus 6. We don't need to do any extra work. I'm going to put this rule right here, because that's the rule we follow when x is bigger than -2. And we've written the piecewise function equation for this entire function. You'll notice that on the previous example I didn't have a choice where I put the less than or equal to sign because the closed circle was given. But sometimes you have to make that choice yourself. You'll see right here both segments overlap at the exact same point. So our equation for the function is still going to look the same. F of x equals, and we'll need two different parts of the rules. We'll start out writing section A, or segment A and segment B. This rule, it looks like, is y equals -1/2 x plus 6. That's the same segment as it was before. Whereas this rule, it looks like we're going to need to do a little bit more work to get the equation. For segment B, I can tell by inspection that my slope is 1/2. And I know that the line goes through the point, it looks like that's 6, 3. Now, we could work backwards. Down 1, left 2, down 1, left 2, down 1, left 2, to get the y-intercept, which appears to be 0. Though sometimes that by inspection is difficult to do, and I would just rather go with the equation. So I'm going to say our equation is y minus 3 equals 1 half x minus 6. And by distributing and solving for y, I get y minus 3 equals 1 half x minus 3. And when I add 3 to both sides, we get y equals 1 half x. So yeah, it did work the same as if we worked backwards, counting down a slope of 1 half to find the y-intercept, but I think going with the equation in point slope form is much easier. So now we know we have our two rules, right? We have one rule, negative 1 half x plus 6, and I have another rule, which is positive 1 half x, and we need to decide when each rule is used. Now you'll notice I'm going to divide my line right around 6, because it seems that 6, if we're drawing that line right here, is when the graph splits, right? So we've got one rule for when we're to the left of 6. That happens to be the rule negative 1 half x plus 6. And I've got another rule that we're going to use when we're to the right of 6, so that's x bigger than 6. And you'll notice that I haven't yet decided where I'm going to put the equal to sign. And that's because it doesn't matter where I put the equal to sign. I can't put it in both. Put right here and right here. You'll see that this is wrong, because what the problem that we run into if we put it in both is that we've got a rule that is sending the input 6 to two different rules. And that, by definition, is not a function. A function is a rule that sends each input to exactly one rule, or one output. So we're just going to randomly choose where to place that equal to sign. Blue is my favorite color, so I'm going to put it right underneath this rule right here. And so now we've got a function that is defined for its entire domain, and it is appropriately labeled because 6 is going only to this top rule. One of the things that some students have difficulty understanding is when they get to choose where the endpoint that is included, or that gets the little underline, is, and when the function, the way it's graphed, tells them where it should be. I'm just going to divide my screen into two, and I'm going to show some examples where you have a choice, and where you actually have no choice because of the way the graph is shaped. So for this example, let's think of a function that looks like this. We'll say this is the point, or the value x equals 5. We've got two rules, and right now I don't care. I'm just going to say f of x equals some line and some other line, right? Or this is actually a parabola. Here we could choose, okay, well, this is x less than or equal to 5, and this is x bigger than 5, because the 2 points meet each other. And this idea of meeting each other where there's overlap, it doesn't matter which rule you follow, you'll get to the same point, so you have a choice in that situation. But say the graph looked like this, where the 2 points don't meet each other. Or we could have it look similarly like this, like we've got one graph that comes up like this with an open circle here, and then the next one that picks off like that. It has no difference, it makes no difference which one's on top or which one's on the bottom, but the fact that they don't meet each other. So I'm going to say that I'm going to call this graph A, or segment A, and this is segment B and segment B. In this situation, this would be the one where it's for x is bigger than or equal to that number, and this would be when x is less than. Where here, we've got x is less than, and here x is bigger than or equal to. I actually suppose now that makes it seem like whenever it's less than, you don't include, and that's not true as well. I mean, I can give an example. If for example, let's take a look at this function where we've got a line that comes up like this with a solid dot right there at 6, and then we have a parabola, an upside down parabola, like that. This graph here, we would say, is defined for x bigger than 6, and this is for when x is less than or equal to 6. Again, we have no choice here, not because this is less than, but because we've got a filled-in circle compared to an open circle.